Okay, so number 45, we have this freely falling object, and they tell us that it takes 1.5 seconds to travel the last 30 meters before it hits the ground. So there's two pieces of information in here, and both pieces of information pertain to the second part of this object's fall. So when you're setting up your diagram for the problem, you need to break this into part 1 and part 2, right? So I'm going to label the first part of the fall 1, so we'll call the displacement for this part of the fall x1, and then we'll call the displacement for the second part of the fall x2. Do we have t1? Do we have the time for the first part of the fall? No. So both of these are question marks. We do know that the initial velocity up here is 0. You can definitely assume that because it's talking about a fall. If something falls, it's a safe assumption that it starts from rest. X2 here is what? 30 meters, but we want to make it negative. Unless, and in fact this wouldn't be a bad idea, would it be acceptable to say that down is positive for this problem? Could we do that? Or no? Could we just say, all right, down, let down be plus? Yeah, that's fine. Situations where the object is only moving down, that would be a time where you would want to do that. At any point, does this ball travel up? No, it's going down the entire time. So you could say that down is plus, and that's fine as long as you stick with that. As long as you stick with that for the whole entire problem, you're okay. So should we do that? I think it's easier. Let's say that down is plus. Okay. T2, the second part of the fall, is 1.5 seconds. And how about the accelerations? What would acceleration 1 be? What's the acceleration for this first part of the fall? It's equal to gravity, which normally is negative 9.8, but here we're going to make it positive 9.8 because we're saying that down is plus. Okay, what's the acceleration for the second part of the fall? It's gravity, which is 9.8, which we'll say is plus. Down is positive for the whole problem. Okay, so the question is this. With this information, we're trying to find the total height that this ball was dropped from. From what height above the ground did it fall? We already have x2. We already know the displacement for the second part of the fall. So basically, what are we trying to find? If we're looking for this total distance, this total displacement, we're basically looking for what? x1. We're trying to find this. Now, how do we go about doing this? The key to the problem is that we have to combine part 1 with part 2. What does part 1 of the fall have in common with part 2 of the fall? Where does part 1 meet part 2? Right here. When the ball is right here, we could call this a final velocity. This point right here, we could call that v final if we're dealing with what? Part 1. The velocity right here is the final velocity for part 1, but it's also the initial velocity. Let's see where I can put it. I'll put it over here. This velocity that the ball has at that point, it's the final velocity for part 1 and the initial velocity for part 2. Does that make sense? That's the key to the problem. What we have to do is we have to connect part 1 with part 2 to solve it. Okay, so let's find an expression. So using part 1 of the fall. So focusing on part 1. What I said is I said v final squared equals v initial squared plus 2a x1. What's v initial for part 1? 0. V initial 0. So v final is going to be plus or minus the square root of 2a x1. Now, whenever you have a square root, it's going to be plus or minus. Which one is it going to be here? Is it going to be plus or is it going to be minus? It's going to be plus because what did we say about down? We said that down was plus. Does everybody agree that the ball is traveling down at this point? Yes. Everybody agree? The ball is traveling down. What did we define down to be? Plus. So this velocity here is going to be, it's going to be a positive velocity. Okay? So this is going to be useful right here. So now let's go to part 2. So for part 2 of the fall, I'm going to use x2. We're focusing on part 2. x2 equals 1/2 a t2 squared plus v initial t2. Now what is this v initial right here? That v initial is the initial velocity for part 2. What are we going to do next? We're going to take this right here, because that's the final velocity for part 1, but it's also the initial velocity for part 2. We're going to plug this in right here. So now we're going to have x2 equals 1/2 a t2 squared plus square root 2a x1 times t2. Now looking at this equation, what do we notice about this equation? How many unknowns are in there? How many unknowns are in the equation right here? Only one. What's the only thing we don't know? x1. The only thing that's missing is x1. And it's what's a bummer? The thing that's a bummer is that it's inside a square root. But you can do it. You guys are good at algebra. You know, we're going after x1. Shaking your head. No. Yeah. So as I said earlier, I don't know if I said it in this period, this class should be difficult because of the physics and not the algebra. Like this is a good example. I would say that you should be able to solve this equation and be able to get x1 from the equation. I would consider that to be basic algebra. If you have trouble doing that equation, you won't enjoy this class as much as you could. The class should be difficult because of the physics, not because of the algebra. Okay, what I would do at this point, and I'm kind of contradicting what I said earlier, kind of what I always say is, don't plug numbers in until you've done the algebra. But honestly, I think it's easier here to put the numbers in now. Would you agree? Let's put the numbers in now. So x2 is what? 30. And I'm going to be really bad physics teacher. I'm going to leave units off because I'm running out of room here. In fact, here's what I'm going to do. I'm going to shrink this up. We need some more room. Okay, so 30 equals 1/2 9.8. Remember, we're saying gravity's positive. T2 is 1.5 squared plus square root 2 times 9.8 times x1. And then T2 is 1.5. So what this is going to give is 30 equals 11.025 plus 6.6408 square root x1. And so you're going to have, so that's going to be 6.6408 square root x1 equals, what's that? 18.975. So then square root of x1 equals 2.857. So then how do you get the x1 out of the square root? You square both sides. So then x1 comes out to be 8.2 meters. So what is this total height that the ball fell from? So you add together x1 and x2, and that gives 38.2 meters, which is the final answer. Yo.
On a problem like this, like on this difficulty level, do you plan all this ahead, or do you first like try to figure out what terms are missing and then?
Oh, like before I do it on the video?
Yeah.
Oh, I wrote it out. So I did this in.
No, like in general. Like I'm saying, what should I do? Should I plan everything ahead, or should I like first try to find the missing terms and then figure out what to do with it?
Well, what I did, so you always start with a diagram, and so the thing I realized is that the key to the problem, and you'll get better at this as the weeks go by, I realized that the key to the problem was combining the first part of the fall, combining the first part of the fall, and the second part of the fall, right? Because the thing we had to do was find x1, but we had data for part 2. So that told me that we had to combine. So then what I looked for is the point that combines part 1 with part 2. So the point that combines part 1 and part 2 is that point right there, and I used velocity. A lot of times the thing that will connect problems is time. You know, you'll find that to be the case as we go along. You know, time is a very common thing that connects parts of problems. Good question.